Hi guys, now let us look at example number 9 on solving trig equations. Guys, here on the left hand side I have cosine and sine combined together, and on the right hand side I have a radical 6. We still want our final answer to be between 0 and 360 degrees. So guys, this is again different than any of the other examples that we did previously, but our goal is still the same. We want to find the value for x, which is basically finding the value for an angle. And then in order to do that, first we have to try and see if we can isolate just one trig function, or we can write factors for the left hand side, or we can solve the left hand side somehow. But guys, there's a few problems with the left hand side. First of all, there's two different functions, so we cannot just isolate one function, and there's no like a direct formula that we can use right away to transform this into just one single function, and then we would have been able to isolate that or solve for one of those trig functions. So we cannot do any of this. We cannot, we can factor 2, but that's not going to really help us that much. So guys, we're kind of stuck with this example. We cannot really figure out a way to solve for the angle. So guys, in order to kind of solve this example, once we are like exhausted with all the things, all the techniques, all the methods that we have learned so far, then one has to like kind of think outside the box and see if we can do something special, something different, in order to simplify this into a form that we can solve. So one of the things that we can do here is we can square the both sides. One of the other reasons that comes to mind when to square both sides is because I see a radical on the right hand side, and we don't like to work with radicals, so it's always nice to kind of get rid of the radicals. But in this particular example, it's not just that radical piece that is bothering us, it is also the left hand side, because we are kind of stuck. We cannot do anything with it except for unless we don't square both sides. So let us square both sides, and then things will start to work out. Guys, if you ask me how do I exactly know that I had to square, guys, there's not like a direct answer to that. It again comes with experience. You keep on practicing and working through different types of examples, then you get these ideas of what other processes or what out of box things you can do in order to simplify or solve for things. Okay, so it comes with experience and practice. If I square both sides, let us start doing it. Then that is going to look like 2 cosine x plus 2 sine x, and I'm squaring left hand side, and I also have to square the right hand side. So guys, let us square left hand side. Squaring left hand side basically means you got to just either you write it out twice, or if you already know the formula for a plus b whole square, then you can just use that one, or you can just write it out twice and you will have to distribute terms. So I write it once, and I write it multiply by itself. And on the right hand side, square and square root will cross out, it's just 6. So guys, left hand side, you got to just distribute this whole thing, and it's going to be, I'm quickly going to write it 4 cosine square x, then 4 cosine x sine x, and then I also have this 2 and this term, so then there's going to be plus 4 sine x cosine x, and then I have 4 sine square x still equal to c. So guys, from here I'm going to try to regroup things, and I'm going to combine like terms. So I'm going to regroup this and this guy. So it's 4 cosine square x. You know what, I'm already going to take out 4 as a common factor between this and this. So it's 4 cosine square x plus sine square x, and then I have this 4 plus 4, because these are basically the same terms, so it's 4 plus 4 is 8. And how about if I'm just going to write it as sine x cosine x, and that equals to 6. So guys, I combine this and this together. I took out 4 as a common factor for them, and then I just added these two because they were like terms. Once I do that, now guys, cosine square x plus sine square x is a very basic Pythagorean identity for the trig functions, and that is equal to 1. So this is equal to 1 means 4 times 1 is 4, and this guy, guys, we are going to let us first just rewrite this, write it just like that, and then we're going to simplify this. So from here, what I'm going to do is I'm going to subtract 4 from both sides, because my goal is to like isolate the trig functions. I still have two functions, two different trig functions, but we're going to transform this into one single trig function pretty soon. So guys, this crosses out. What do I have? I have 8 sine x cosine x equals to 6 minus 4 is 2. Guys, let us hold on to this, and from here, guys, since these are still two different trig functions, we cannot still solve for one particular trig function, so that could help us to find the x finally. So what I'm going to do here is, guys, again, we have to recall some of the trig identities and things that we have learned in the prior sections. So guys, this guy, I can rewrite this, and I'm going to rewrite this as 4 times 2 sine x cosine x for a particular reason, which you will see in 1 second. Why did I write it as 4 times 2? Because, guys, this is a nice identity, which is also called as a sine double identity. Let me quickly remind you, and you can find it in your formula sheets. Sine of 2 theta is equal to twice sine theta and twice sine theta cosine theta. So if this is equal to this, then obviously the right hand side is also equal to the left hand side. Then we can just rewrite this or replace this by 4 times sine 2 theta equal to just 2. So now we only have the sine function. We already got rid of the cosine. How did we get rid of that? Because we had a nice sine double angle formula. Guys, from here I can divide both sides by 4. What do I get? I get sine of 2 theta is 1/2. So we were able to isolate the sine, right? Sine function, although we have 2 theta here, but we already know how to handle the 2 theta. I have already shown you an example where we had to solve for a 2 theta, right? I think it was a tangent of 2 theta, but we have to use the same idea. So guys, I'm going to get rid of some of this stuff here, and then we can go ahead and solve for this angle. And there's few other things that one has to keep in mind with this example. So I mean, that was one of the reasons why I chose to show you this example. Let us get rid of this. Now, so sine 2 theta, from here I'm taking it up right here. Guys, sine of 2 theta is 1/2. Okay, now before we proceed, guys, let us remind ourselves, I don't know why I said theta. This is supposed to be an x, because I know why, because I wrote the general form for sine 2 theta, so I got carried away and I used theta. But guys, this is all in terms of x. We got to be consistent, so it is 2x. Good. So guys, here we already know that x is restricted between 0 and 360 degrees, right? But for this particular equation, first of all, one has to evaluate the value for 2x, not just x. So once one has a value for 2x, then you can divide by 2 and get the value for x. But if x is restricted between 0 and 360, obviously one cannot assume that 2x will also be restricted between the same limit. No. So one has to do some extra work to figure out what are the restrictions for 2x. That is not too complicated. And guys, I have already done this in one of my other examples. Now, if I write this out as an inequality, so I'm writing this form in an inequality. So if I write it in an inequality, now I can multiply the middle term by 2 because I want a 2x here. If this was a 3x, then I would multiply by 3. So if I multiply this inequality in the middle by 2, then obviously I got to multiply the left hand side by 2. So 2 times 0 on the left hand side will still be 0. And on the right hand side, it's going to change. It's going to be 2 times 360, which is 720 degrees. So guys, keep this in mind. One has to do this step if one is first solving for twice 2x. We cannot directly solve this for x. We have to first solve for 2x. So what does that mean? Guys, first of all, this means that we only have to go around the unit circle once. But to write the values for twice x, we have to go around the unit circle twice. So in this case, we may only get 2 values, and we know we'll get 2 values because sine is positive. I mean, in this case, sine is 1/2, which is positive. Sine is positive only in 2 quadrants, so that means we'll have 2 solutions. But now, if we go from 0 to 720, so we're going around twice, then we will have 4 solutions rather than 2 solutions. So guys, that is why it is important to do this step. If we exclude this step, then we'll only get 2 values, but there could be 4 values as well. Okay, so that is an important step. Now, once we figure this out, we have the range for 2x. To find the value for 2x, guys, what we have to do is we have to 1/2 is we can see 1/2 on the unit circle. So I'm going to look at my unit circle and I'm going to look for the sine values which give me 1/2. So positive 1/2 here, I already know I only have to look in the first and the second quadrant. So in the first quadrant, I get 2x equal to 30 degrees. That is one of the solutions. Then in the second quadrant, what do I get? I get 2x equals to, we know sine is the y value on the unit circle and cosine is the x value. I get 150, right? But guys, these are not the only two values. These are the values if you just go around once in the unit circle, but we can go back again. So going back again simply means that you just have to, going back again means you just have to cover the whole 360 to get back to the same angle. It is still going to be the same angle, but you have to kind of add 360 to both of them. So you have to add 360 to this to get back to the same angle, right? It's like a coterminal angles. So when I add 360 to this, I get 390. So how did I get the 390? I already had my initial reference angle. I just added 360. Why did I add 360? Because I have my range for 2x is not limited to only 360, not limited to only once going around the unit circle, but I'm allowed to go once more around the unit circle. That's why I'm adding that 360. And if you like, if you draw these angles, guys, it would be more easier for you to actually see why we are adding 360. So it is equal to 390 degrees. Same thing with the other one, guys. Got to add 360 to this. So 150 plus 360. If I add these, I'm going to get 0, 11, so 510 degrees. So guys, for 2x, we already knew we were going to get 4 angles, and that's what we have. But we don't need 2x, we need x. Now, once we have 2x, we know how we can evaluate the value for x. You just have to divide both sides by 2. So let us go ahead and, guys, let us go ahead and do that one. So for each of these, let us start with the first one. The first one is, this implies x is 15 degrees. I'm going to circle these things. This implies x is 150 divided by 2, which is 75. This implies x is 75 degrees. Guys, what does this imply? This implies x is 390 divided by 2, which is, what do I have here? 195 degrees, right? Let us make sure 390. Yeah, and then this implies x is 255 degrees. Guys, these are the 4 values for x. Now, one would say that, okay, we have 4 values and those are the answers, or those are the solutions for this particular equation. But guys, keep in mind this has a radical in there. So I'm sure you have seen these type of radical equations, not exactly with the trig functions, but in general algebraic radical equations. Guys, when we have radical equations, there is a possibility that the solutions that we obtain by using the regular process, whether it is using a quadratic function process or a simple linear process, we may get some answers that are actually not the solutions. So we like to think of those as extraneous or extra solutions. Guys, this is that example where we have some extraneous solutions which actually do not satisfy this given equation. And in general, guys, once we find solutions, we should go back and verify whether the solutions actually work. That is a very important part of this whole mathematical calculations, or a big part of mathematics in general, guys. Verifying, going back and checking your answers if this answer actually makes sense, if it is a correct answer. So in this case, we are going to make sure we're going to go back and we are going to substitute these values one by one onto the left hand side for x, and we're going to verify if they satisfy the equation. Okay, so I'm going to get rid of this. First of all, I'm going to start with number 1. What is number 1? X is 15 degrees. So I substitute x 15 here for on the left hand side. So what do I have? I have 2 times cosine of 15 plus 2 times sine of 15, and we want to verify whether this left hand side equals to the right hand side, which is radical 6. So guys, I used a calculator to simplify the left hand side and then also the right hand side. So when I simplify the left hand side using the calculator, I got something close to 2.4499, and then the right hand side was exactly the same thing. So it satisfies the equation. So that means x equals to 15 degrees is definitely one of the solutions. Then guys, I tried using x equals to 75. x equal to 75 degrees. Same way, guys, I substituted back. It also worked out. Left hand side was equal to the right hand side. Then, guys, third one, x equal to 195 and x equal to 255. When I substituted these two one by one on the left hand side, we were not able to verify that the left hand side is equal to the right hand side. Usually what happened with both of these, on the left hand side, guys, on the left hand side we get negative 2.4499, but we already know that that is not equal to positive 2.4499. On the right hand side I have a positive 6. So these two were extra solutions, extraneous or extra solutions. So we got to ignore these two. Although in calculation we found those solutions, and I'm sure that you have already seen in algebra and pre-calc a lot of these equations, maybe rational equations, sometimes I know the radical equations, they have solutions that do not actually work and they are thought of as extraneous solutions. So guys, the point here is that, so these two are the only solutions. First, let us make sure of that. And then guys, the main point that I'm trying to get across here is that when we have equations like this, there's a radical here. We had to do some extra work of squaring and all that, and then using a trig identity. But the key thing was that once you get all the values for the x, you cannot just say that for sure. You cannot say that those all are the solutions. You have to go back and you have to substitute back, and then from there you got to verify whether all of them are solutions or only some of them. In this case, we could see that there's only two of them that actually work and the other two do not. So guys, be careful when you're working with these types. This was like, you can think of this as a challenge problem as well, but I still wanted to share this with everyone. Okay, guys, practice these problems.